All right, thank you for joining us this evening for our next installment of the Young Scientist webinar series. Tonight, we are going to be hearing from Toby Harbison on You Are What You Eat, understanding the relationship between commercial fishing and the feeding ecology of Dungeness crabs using isotopic and gut content analysis. And next month, our talk will be on understanding adaptive capacity and analysis of community perceptions and policy responses to ocean acidification and other marine stressors on the West Coast. I apologize for my little dog barking in the background. And a little quick introduction about the Cape Perpetual Collaborative. My name is Tara Du Bois, and I am the communications coordinator with the Cape Perpetual Collaborative. And our vision is to foster conservation and collaboration within local communities for scientific exchange, management, and awareness. And our three guiding principles are community engagement, leveraging resources, and engaging in partnerships. And as you can see at the bottom here, we have a variety of founding partners that include federal agencies, state agencies, as well as a nonprofit, local nonprofits, and the Confederated Tribes of Coos, Lower Umpqua, and Siuslaw Indians. And our focus is around the Cape Perpetual Marine Reserve. It's Oregon's largest marine reserve in Oregon. And fun fact for today is we have a variety of visitor resources on our website. At capeperpetualcollaborative.org. And one of those is a coloring book that Surfrider Foundation put together. And you can download this color book and help Ollie the octopus clean up plastic pollution in the ocean. If you head to our website and scroll all the way down to the bottom under visitor resources, you'll see a link where you can download that as well as other visitor resources. We also host a variety of community science projects. Some of them are monthly and some of them are seasonal. And we also host a Cape Perpetua winter speaker series on Saturday mornings through the end of March. If you are interested in any of these opportunities, do feel free to go to our website and you click on our events tab and you will find all of our events there that we have posted. And we do keep that up to date, so check it out. And I always like to encourage folks to join us on our Facebook page at the Cape Perpetual Marine Reserve and our YouTube channel. And with that, I'd like to introduce our speaker, Toby Harbison. She is a second-year graduate student in the Marine Resource Management Program and works with Dr. Sarah Henkel at Hatfield Marine Science Center. She grew up surfing, sailing, kayaking, and generally spending as much time as possible in the ocean down in Santa Barbara, California. That sounds lovely. During undergrad, she mapped larval spiny lobster habitat using GIS in the Turks and Caicos Islands with the School for Field Studies. Toby earned her bachelor's degree in American Studies from the College of William and Mary in 2011. Since then, she has worked as a naturalist, wilderness guide, park ranger, and science curriculum development specialist in various locations, including Channel Islands, National Park, Southeast Alaska, and Missoula, Montana. And I can't see the bottom line of this. Toby, what does it, you love my bar is showing up over this.
It says, she loves experiencing diverse cultures, watching murder mysteries, herbalism, and taking care of animals.
Well said. And with that, I'm going to let you take it over from there. And we will be holding a Q&A at the end of Toby's presentation, and I believe she mentioned she might offer the opportunity to ask questions in the middle too. So we will open that up at the end. So feel free to add your questions to the Q&A or chat section as you think of them, and we will get to them at the end. And with that, Toby, it's all yours.
All right, thank you so much for that lovely introduction. I'm happy to be here this evening to have the chance to share a little bit about my research on the feeding ecology of Dungeness crabs. So we will talk about understanding the relationship between commercial fishing and the feeding ecology of Dungeness crabs using stable isotope analysis, gut content analysis, and fisherman interviews. So the Dungeness crab fishery is one of the most profitable fisheries on the west coast of the United States. And in Oregon, commercial fishermen catch an average of about 16 million pounds of crab each year. And the money that crabbers earn from those 16 million pounds per year comes between $33 and $74 million annually. So it is a huge industry. It's very economically and ecologically significant to the west coast of the United States. The Dungeness crab population ranges all the way from Point Conception down in California, all the way up to Unalaska, Alaska in the north. So given that this fishery is so important, that it has such an economic impact on the west coast, we must know everything there is to know about Dungeness crabs, right? Right? Well, wrong. There's still a lot that we don't know about Dungeness crabs, and especially about what they eat and how changes to the environment might impact Dungeness crab populations. So I wanted to ask a question. So Tara, maybe you can help me out with this. I wanted to see if someone can tell me, how do you tell the difference between male and female crabs? And
See if anybody pops
see
on.
if you can type that in the chat.
Yeah, I'll see if anything pops up.
So if you have an answer, how do you tell the difference between male and female crabs? Go ahead and type that into the chat box.
There's a question, are they asexual?
They are not asexual.
And then somebody else says, my daughter says their butts. Another one is the size of their claws, their undersides.
Ooh, the
Bottom's
undersides.
pointy or oblong.
The undersides is the closest answer I've heard. All right, so you can tell the difference between male and female crabs by the shape of their abdominal flap. You can see that the abdominal flap underneath the male crab has this sort of obelisk long shape. It's a bit more phallic, if that helps you remember, whereas the female abdominal flap is much more rounded. And this is significant to this particular topic because commercial and recreational fishermen are only allowed to keep female crabs. I want to give a little bit of background information on the life history of the Dungeness crab before I jump into my research in detail. And this will be important to understanding the hypotheses related to my research. So mating occurs in the springtime, and the female crabs hold between 1 and 2 million eggs under their rounded abdominal flap for 2 to 3 months, and then the eggs are released in fall, winter, or early spring. They hatch in the winter or spring, and they go through several different stages of metamorphosis. So they go through this stage where they are zoea, and then they metamorphose into megalope, and then they become juvenile and adult Dungeness crabs. So the megalope appear in early spring, and it turns out sometimes they actually hitch a ride on Velella velella, which I'll show a picture of in a moment. And they molt into juveniles in April or May. Now, this is important because I am studying what the Dungeness crab eat, and it turns out that they eat each other quite a bit. There's a lot of cannibalism that goes on in the Dungeness crab populations. And so a lot of cannibalism occurs among the juvenile crabs when they first make their way into the estuaries in the springtime. Juveniles spend most of their time in the protected waters in the near coastal zone and in estuaries, And as Dungeness crabs mature and become adults, they tend to spend more time offshore. All right, so I just wanted to show this is a Dungeness crab megalope, and these are the Valella little jellies that sometimes the Dungeness crab will hitch a ride on those when they're going inshore. All right, so it's not every day that you talk about cannibalism, but it's pretty commonplace among Dungeness crabs. Many authors report cannibalism between and within age classes of Dungeness crab, and several authors have noted that cannibalism is most common among the juvenile or young Dungeness crabs that are under 66 millimeters across on their carapace. But sometimes larger crabs eat smaller crabs as well. And it's thought that cannibalism in the Dungeness crab population creates cyclical fluctuations in population abundance within Dungeness crabs. Right. All right, so in my research, I am looking into Dungeness crab diets and their feeding ecology, researching what they eat and how it changes seasonally. So I wanted to go over some of the wild prey sources for Dungeness crab. Some of the major categories of prey that they eat include crustaceans, bivalves, fish, and also diatoms, which are a type of plankton. Some of the major crustaceans that they eat are crayon shrimp and, of course, juvenile Dungeness crabs or other Dungeness crabs. They also eat a lot of bivalves, see 3 different species here, and they're pretty good hunters and they're very quick, so they can catch and eat a lot of fish species as well. And these are 3 of the most common types of fish that Dungeness crab eat: the Pacific sand lance, Pacific sand dab, and lingcod. All right, now motivation for this research started with some benthic box core sampling that my advisor, Dr. Sarah Henkel, did as part of her monitoring of the pack wave energy test sites off the coast of Newport, Oregon. So Dr. Henkel was studying what organisms live on the seafloor off the coast of Oregon so that we could know in the future if wave energy development has an impact on the organisms that live in that area. So in order to do this work, Dr. Henkel went out and took benthic box cores, and this is a benthic box core right here. This device essentially takes big scoops of sand and sediment and organisms from the seafloor so that you can see what is living down there. Now, in doing this work, Dr. Henkel saw that there was minimal prey available for Dungeness crabs to eat. So she started pondering what Dungeness crabs might be eating and where they're getting all of their calories. Additional motivation for this study came from literature, and one researcher in particular, Holzman up in Willapa Bay, Washington, did a study on the diets of juvenile Dungeness crabs and found that the crabs in the bay would deplete their prey biomass, everything that's available for them to eat, in about 17 days. So this showed a lack of available prey. So that raises the question, if there isn't a lot of prey out there for the Dungeness crabs to eat, where are they getting calories from? And Our hypothesis is that Dungeness crabs might be getting calories from the commercial Dungeness crab fishery, and specifically from bait that is input into the system through bait discards from the fishery. So thousands of pounds of bait are added to the marine system from the commercial Dungeness crab fishery every year. A variety of different baits are used in Dungeness crab pots, especially squid, sardines, clams, and other fish like mackerel and bonito. Okay, so we know that thousands of pounds of these baits are added to the marine system off the coast of Oregon every year. So we want to see if we can find evidence for Dungeness crabs eating this prey, or excuse me, eating all of that bait. So here we can see a chart from ODFW data. This data comes from fishermen log books, and it reports the total poundage of different types of bait that are used in commercial Dungeness crab pots. So we can see that some of the most important bait types are clams. These are a variety of types of clams, including cockles and butter clams, squid, sardines, and mackerel. Okay, so another motivator for this study is that despite the fact that fishing effort has increased within the commercial Dungeness crab fishery in Oregon, with new fishermen entering the fishery, we have not seen a decline in Dungeness crab populations. There are some fluctuations in Dungeness crab populations that might be related to cannibalism, but we don't see an overall decline in Dungeness crab populations. They are healthy and the fishery is sustainable. So then we're asking ourselves, why is it that if there are more fishermen and more fishing effort being put into this fishery, then why aren't the Dungeness crab populations declining? And we think that might be because the fishermen are actually unintentionally farming crabs by adding all of that bait to the system. All right. Now, of course, we don't know if all of the bait from the commercial Dungeness crab fishery is making it back down to Dungeness crabs. Fishermen stuff their pots with a variety of baits. They set their pots, they let them soak, and then they pull up their pots, take the harvested crabs, and then they'll dump the used bait, more often than not, right overboard. So some of that bait might make it all the way back down to the seafloor where Dungeness crab could eat it, but we don't necessarily know that all of that bait will make it down to the seafloor. It's perfectly reasonable to think that a lot of that bait would be eaten by seagulls following the fishing vessels, or by sea lions or other scavengers that are on the seafloor. So we want to try to assess how much of that bait is getting to the Dungeness crabs and impacting their diet. And this is just a little video of Dungeness crabs eating a chunk of, looks like mackerel to me. So there have been previous studies that look at the impact of fishery baits on commercially significant benthic invertebrates, specifically lobster. So researchers have described caloric contribution of bait to commercial lobster fisheries in Maine and also in Australia. And in Maine, they have shown that populations are supported by that bait. There have also been a lot of studies done looking at the impact of adding organic material more generally to marine systems, looking at detritus from trawling vessels and aquaculture. But this dynamic has never previously been studied with a targeted focus on the Dungeness crab fishery on the West Coast, or for that matter, in Oregon. All right, so our hypothesis is that we will see cannibalism in the springtime, evidence of cannibalism in the springtime when all those juvenile crabs are molting into their juvenile form, when they are eating each other. And we expect that we would see the most evidence of wild prey in the late summer and fall, when there aren't as many juvenile crabs around to eat, and when there isn't as much bait input from the commercial fishery. And we would expect to see the strongest signature from bait after January, from January to about March, when the commercial Dungeness crab fishery is the most active. All right, so I just wanted to pause really quickly and see if anyone has any questions on anything I have talked about so far. So you can go ahead and type those questions into the chat and they will be read out for me to answer.
So we did have a couple questions here, and you might have just answered one. It says, seems like a lot of empty crab shells wash up on shore here during the summer. Is that from molting?
Yes, that would most likely be from molting. Yeah. And crabs molt more than once a year when they're growing to their adult size, but when they are small, they'll molt more than one time per year.
Oh, okay. And where is the squid bait coming from?
The squid bait comes from all over the place. A lot of it comes from South America. I know the waters off of Argentina. Some of it is local squid as well. So it comes from the Pacific Northwest.
And then what is marine snow?
Marine snow is organic material, basically dead organisms that fall down to the seafloor. So it's a bunch of organic matter that ends up on the seafloor. And it's possible that Dungeness crabs eat that dead organic matter on the seafloor directly.
And then this person says, didn't see any mention of all the old chicken we see folks use a lot as bait. Any extras on that?
Yeah, so that is a good question. In my research, I've seen that a lot of commercial Dungeness crab fishermen don't use chicken, but I know that it is used a lot in the recreational fishery. So chicken does end up in the ocean, and in fact, I have used a lot of chicken as bait myself, but it's not a part of the commercial fishery.
Got it. And then are the fisher people using the bait purposefully to feed the crab, or is it surplus from other fishing they are doing?
So sometimes they will get the baits from like scraps from other fisheries. Like if some fishermen are going after rockfish, they'll fillet them and then use the carcasses as bait. But that's more of the smaller scale commercial fishermen. On the larger vessels, they're buying bait for the purpose of catching Dungeness crabs.
Okay. And then just a couple more here, I think on ones you've covered. What is the range of the Dungeness crab, and what are their natural predators?
The range of the Dungeness crab is from Point Conception, which is about halfway down California, up to Alaska in the Aleutian Islands.
do they stay in their kind of, do they migrate that whole distance, or do they kind of stay in an area?
There is a lot of movement of crabs within that population. So I would be surprised if a crab made it all the way from California up to Alaska, a single crab, but there is a lot of genetic flux and a lot of movement
Got it.
within that population.
Okay. And then how about their who are their natural predators?
They're natural predators. They're eaten by birds, sharks, sea lions, other larger marine mammals as well.
Got it. All right. And I think that wraps the questions for now.
Okay. I will
for
keep on
that
going.
portion. Yeah.
Okay. So in order to assess seasonal changes in Dungeness crab diets due to inputs from the commercial fishery, cannibalism, and wild benthic prey, I used 3 different strategies. I interviewed fishermen, I conducted stable isotope analysis, and I also looked inside of crab guts. All right, so let's start with the fisherman interviews. So my goal in interviewing fishermen was to get more fine scale information about bait use strategies on the Oregon coast, and also what types of bait were used, where they're used, and the spatial distribution of those baits. I had information on the total pounds of each bait type used from ODFW logbooks, but I wanted more details so that I could understand what types of bait were being input to the system at different times of year and in different areas along the coast. So I developed a survey in collaboration with the Oregon Dungeness Crab Commission, as well as Bob Etter, who is a veteran fisherman out of Newport, Oregon. And I put a survey into the online survey platform Kobo Toolbox. So I did that so that fishermen could fill out the survey online, or they could complete the survey over the phone with me. Most of the interviews were conducted over the phone. I believe 17 were conducted over the phone and about 7 were conducted online. And it was a lot of fun to talk to the fishermen. They gave me a lot of information, which was awesome. And the participants in the study came from all over the Oregon coast. I wanted fishermen from the whole range of the coast. So they came from Port Orford all the way up to Warrenton. And these are just some of the basic results on fishing strategies that I saw from the fishermen. So I learned that there are a range of soak times that the fishermen use. So soak time just means how long they leave the crab pot in the water. And these are averages, but I found out that soak times are very short at the beginning of the season, because that's when they expect to have most of their catch is right at the beginning of the season, and that they tend to leave their pots out longer later on in the season. But overall, the minimum soak time on average is about 1.06 days. The mean soak time is about 3.29 days, maximum soak time 7.45 days. I also wanted to understand how deep they set their pots as well, so I could understand what part of the continental shelf those pots were ending up on. So the average minimum was 10.38 fathoms. A fathom is 6 feet. So that's about 60 feet. The mean depth was 29.89, maximum depth 74.79. I also wanted to see how far they would travel from their home ports in order to set their pots, so that I could understand a little bit more about the spatial distribution of the crab pots from fishing ports. So the minimum distance was 8 nautical miles, maximum 74.09. And I asked about how much bait they put in each pot. On average, it came to about 3.11 pounds of bait per pot, but that's just an average. And fishermen reported that they put a lot more bait in the pots at the very beginning of the fishing season than the end of the fishing season. All right. And let me just tell you what that fishing season is, okay? So the fishing season usually starts in December, but in 2019, the fishing season did not start in December because the crabs were not full of meat yet. So the Oregon Department of Fish and Wildlife does tests in late November and December to see how much meat is inside the crabs, because no one wants to buy a crab from the store and find out that it just has a tiny bit of meat inside of it. So once the crabs are full enough of meat, once they meet that threshold, then the fishery will be opened. Okay, so I was studying the season that opened in January 2020 and it closed in August. So generally the fishery is open from December through August. This shows the number of participants in my study who fished during each of the months that the fishery was open in 2020. So a lot of fishermen were still able to get out and fish despite the COVID-19 pandemic. You can see that fishery participation is the highest in the beginning of the season, and that a lot of fishermen drop off towards the end of the season. There are fewer fishermen operating in the summer, and a lot of that depends on the return on investment for fishermen. So a lot of the larger vessels will drop off earlier because it's more profitable for them to switch over to a different fishery, but a lot of the smaller vessels will fish longer because they just have one type of gear and they just fish crab. Okay, so going back here, these are the types of bait that fishermen in my study used, and I have it next to the chart from the ODFW data on the right. And so the left is the results from my interviews, and you can see that squid are the #1 bait used in both. Clams are very important in both, but significantly rockfish was the #2 most used bait in my study. But according to ODFW data, there wasn't very much rockfish used. So that's interesting to see that. And I think one reason for that is because a lot of rockfish bait that's used is scraps from recreational fisheries. Some of it is purchased from bait distributors as well. But I think that this might not account for all of those scraps that are coming from recreational fisheries because the fishermen don't have to buy them. And sometimes logbook data isn't exactly precise. So it was interesting to see that there was so much more rockfish revealed in my study. The fishermen use different bait strategies when they're fishing, and the strategy that they use can affect how much bait the crabs are eating. So some fishermen will use these chew bags, they're called, and the crabs can actually access the bait that are in these chew bags. And so they can eat the bait while they're in there. And some fishermen use these bait jars that don't allow access to the baits. And so obviously, if you have crabs in a pot that has a lot of chew bags, they're going to be able to eat more of that bait. Some fishermen also will take pins like this and just pin a whole carcass into the pot, and the crabs have access to that. Okay, so if you think about crabs that might end up in a crab pot, you might have a bunch of small male crabs. you might have a bunch of female crabs and you might have a bunch of large male crabs. In order for the crab to be big enough to be kept by the commercial fishermen, they have to be over 6¼ inches. Okay, so there might be females and sublegal males that are hanging out in the pots that are eating the bait, especially if it's pinned in there or if it's in a chew bag. And so they get a bunch of that bait and then they just go back into the ocean. Okay, so it's a caloric subsidy for them. The large males are kind of out of luck, they get eaten by humans. All right, so those are some of the initial results I had from my interview data. I've only just scratched the surface on the interview data. There are a lot of things that I can do with that data, but I just wanted to show you one sort of exploratory analysis that I did looking at the fisherman interview data. So for each major bait type, like squid, clams, herring, mackerel, etc., I asked the fishermen, do you use that bait type or not? If they said yes, I gave them a 1 in a column. If they did not use that bait type, they got a 0 in that column. And so what I ended up with was a binary string of 0s and 1s for each interviewee. And I used those binary strings for bait types to construct these correlation matrices in R. So these correlation matrices show you which participants' answers are the most similar to each other and which are the most different from each other. And I started by looking at if there is a relationship between the region of the coast, so north, central, or south, and the strategy of bait use that was used, or the types of bait that were used. And so this is what I ended up with, these bait use correlation networks that you see here down at the bottom of this slide. Over here, I have each of the participants listed by the region where their home port is located. And over here, I have their home ports. So you can see that there's no clear north-south relationship to different types of baits that are used that has been revealed by this analysis. But one thing that I noticed is that a lot of the Newport fishermen ended up at the center of this network. And from my analysis, I saw that the Newport fishermen used a wide variety of baits and that their strategies were central to the network in addition to being central to the coast of Oregon. All right, so those are the interviews, but the main analysis that I'm doing for this research is stable isotope analysis and gut content analysis. So my advisor, Dr. Sarah Henkel, and I went out and collected crabs from the 3 regions of the coast, north, middle, and south. And our goal was to collect 10 legal males, 10 sublegal males, which is under 6¼ inches, and 10 female crabs from the north, central, and south regions of the state in every season. Once we collected those crabs, our first step was to eviscerate them. So this is the inside of a Dungeness crab. This is a nice, clean, pretty picture. This one is what it actually looked like more often than not. Kind of a jumbled mess inside of there. But in this picture, you can see where the stomach is. So that's the stomach right there. So I'd remove the stomach and then put the stomachs in ethanol and open them up and look at what was inside. And I did this with help from my super intern, Julia Dang. These are images of some of the items that were found inside of the Dungeness crab stomachs. Here we have a fish scale, some fish bones. These two are pieces of crabs, of decapods. This is a little snail that you see in there, and some pieces of bivalve as well. So what Julia is working on is making tables of what species are present in each of the samples, and that work is ongoing right now. Next thing that we did was we conducted stable isotope analysis. So the guts went to the gut content analysis, then we took the leg meat from the crabs, we put it in a drying oven, and then we ground that leg meat into a fine powder for stable isotope analysis. After the leg meat was a fine powder, I took a little tiny scooper and scooped 1 milligram of that powder into these little teeny tiny tin cups and rolled them into a ball and put them in a 96 well plate. All of that grinding of samples made my forearms very, very strong. So that's actually my forearm. Kidding. All right, then I put the samples through a mass spectrometer to look at stable isotope values. And I actually personally didn't do this. These samples were run in a NOAA lab up in Ock Bay near Juneau, Alaska. So what are stable isotopes? I've been throwing that word around, but what does that actually mean? Okay, so the sum of protons and neutrons give an element its atomic mass, and the number of neutrons defines what isotope that element is, or what isotope of that element you're looking at. Okay, so I used carbon and nitrogen isotopes. And so an example is 99% of carbon is the carbon-12 isotope. The carbon-13 isotope has 1 extra neutron. Okay, so 6 plus 7 is 13. That's why it's a carbon-13 isotope. So the isotope with 1 more neutron is called the heavy isotope, and the one that has 1 fewer neutron is the light isotope. So in stable isotope analysis, basically what we do is we look at the ratio of the heavy isotope to the light isotope, and that can give us information about the diet of the animal or plant that we are looking at. So the stable isotope ratios are expressed with this delta symbol, and it's according to this equation. So this is the ratio of the molar weights of the isotopes minus 1 times 1,000. And for my work, I looked at the ratio of carbon-13 to carbon-12 and nitrogen-15 to nitrogen-14. So we have delta-13C and delta-15N. So we can plot the values for delta-13C and delta-15N in what we call isotope space. So this is isotope space here. The higher values of nitrogen of delta-15N indicate higher trophic levels. And different delta-13C amounts indicate the carbon source. So you can tell the difference between terrestrial organisms and marine organisms and estuarine organisms. Okay, so for this study, a lot of our values are going to fall into this mixed marine terrestrial economy here. So basically in between the marine system and the terrestrial system, because the crabs inhabit estuaries and the near coastal area that is between the terrestrial system and the marine system. Okay. And to touch on my expected results again, in the springtime, we expected to see the strongest bait signature from the commercial fishery. And in the late spring, we expected to see some influence of cannibalism, which would increase the delta 15N values, but have similar delta 13C values. And in the fall and late summer, we expected to see lower nitrogen values and lower delta 13C values from the crabs eating a bunch of wild prey from the seafloor. Okay, so here are some of my results, my initial results. This is delta space, and these are ellipses that have been drawn around the samples from winter, spring, and summer. So these are the winter values, spring and summer. We see higher nitrogen values in spring than in the winter time, and we see lower carbon 13 and nitrogen 15 values in the summertime. So this does align with our hypotheses. So some good initial results there. You can see that the picture looks a little bit different when we're looking at just legal males, but we do see lower nitrogen values in the summertime and carbon values in the springtime that would that might suggest that has been more bait input to the system because we're seeing values that would come from marine organisms rather than estuarine organisms. So those marine organisms or pelagic organisms could be the squid and mackerel and herring that were added to the system from the commercial fishery. Here we see that the feeding of females by season in 2020 did shift from spring to summer. So we see the females eating higher up on the food chain at higher trophic levels in the springtime. That might indicate bait input, and at lower trophic levels in the summertime. So values on this side indicate more of a estuarine or terrestrial signature. Moving out to the open ocean on this side, we see that as crabs grow, they move more towards a pelagic or open ocean bait or feeding signature. One thing that I have found that is extremely significant is that I saw very striking differences between the feeding of males and females between 160 and 170 millimeters. So the large size males and females seem to be eating different things. Okay, so the females seem to be eating food that comes from the estuary or closer to the terrestrial system, and the males seem to be eating food that is more from the open ocean. Previous studies have not shown this striking difference between the feeding of males and females. So it's exciting to see those results. And down here, we see that, or this is the distribution of the data. So this is the number of crabs from each of these sizes in millimeters that were input into this model. So my next step will be to run stable isotope mixing models. So far, I have been looking at what's called a trophic niche. So what types of organisms the crabs eat and how those diets shift from season and season and vary among different sizes and sexes. But next I'll be able to actually look at the proportion of the diet that comes from different food sources using stable isotope mixing models. So here, all these little dots here represent the consumer that you're studying, and these represent different food sources for those consumers, and you can run analysis to determine what proportion of these organisms' diets comes from each of these food sources. And I haven't done that yet because I don't have the stable isotope results back from the lab yet. So this is all ongoing. Once I do get those results back, you can actually look at the proportion of the crab's diets that come from different food sources. So this is just an example of what that might look like. And this study is very significant because if our hypothesis is valid, then changes to the commercial Dungeness crab fishery could have widespread ecological and economic effects on the west coast of the United States. So our hypothesis is that bait from the commercial Dungeness crab fishery is feeding Dungeness crabs and might even be supporting their populations. So that means that if the fishery is closed for whatever reason, then those crabs might end up with less food to eat. And of course, that would affect their population size, which would in turn affect the fishery and the economy on the West Coast. So have some pretty interesting ramifications. This is especially important right now because there have been a lot of disturbances to the commercial Dungeness crab fishery. There have been harmful algal blooms that produce domoic acid poisoning. And so the fishery has to be closed if any of these harmful algal blooms are detected, because the harmful algae can end up inside of the Dungeness crab. So that has been something that has occurred, especially in the northern part of the Oregon coast. There have been fishery closures from harmful algal blooms. There's also been an increased incidence of whale entanglement in fishing gear, especially in the southern part of the coast of Oregon. And so there have been closures from that. And then there have also been changes to the fishery from the COVID-19 pandemic, which sent the global economy into flux, shall we say, and changed the amount of fishing effort that occurred in the fishery when there were a bunch of lockdowns, and decreased fishing effort for a period of time in the spring of 2020. All right, so I want to give a big thank you to the Oregon Dungeness Crab Commission, Hatfield Marine Science Center, and Oregon State University for contributing to my work. I also want to give a big thank you to my advisor, Dr. Sarah Henkel. A lot of these ideas came from her, so I wouldn't be able to do this research without her. My funding source is the Bill Wick Marine Fisheries Award, and my committee members are Dr. James Watson and Dr. Mark Novak. I also want to say thank you to Bob Etter, the fisherman. His input on this study has been incredibly useful, and he's given me a lot of contacts up and down the Oregon coast. So wouldn't be able to do it with Bob Etter either. And of course, a thank you to the Cape Perpetua Marine Reserve Collaborative for giving me this opportunity to talk about my research. All right, and I'd like to open it up for questions.
Fascinating. So I do have a couple questions that came in. How much of the bait is eaten, and does its decomposition cause oxygen depletion?
So a lot of it depends what you mean, what types of organisms are eating them. Almost all of the bait that is accessible to crabs in the pot is eaten by crabs in the pot. As far as bait that's eaten once it's discarded overboard, we don't know how much the crabs are eating. A lot of the bait that's in the closed bait boxes is actually eaten by small scavengers like isopods.
Right.
And what was the second part of that question?
And it was, does its decomposition cause oxygen depletion?
It could, yeah. Organic material could cause a decrease in oxygen.
And then let's see, do they eat as much when they molt?
So the females, the females molt, and then immediately after they molt is when they mate, and then they'll hunker down and not eat while they're brooding. So the females will not eat as much after they have mated, right after they molt.
Right. Are they really soft right after they molt too?
Yeah, the females are really soft. So usually a hard shell male will mate with a soft shell female.
Wow, interesting. Huh. The crabs have to reach a certain weight before the season can start, before the bait is available, but it sounds like there's a shortage of food in late fall. Is this correct?
So in the late fall, the crabs still have wild prey available. They just don't have the additional calories from the fishery, because the fishery is closed in the fall. And there's probably less cannibalism going on because there aren't all those little tiny juvenile crabs around to eat.
Mm-hmm. Should the fishermen consider a particular bait to increase crab numbers?
That's a good question, and we've actually kind of that's one avenue of future analysis that we want to look into. We've looked at how many calories different baits have to see if they can increase calories to the seafloor.
Right. Huh. Do our fishermen have any ideas to reduce whale entanglements, such as changes in equipment?
I am not an expert in whale entanglement, but I have heard about some cool new prototypes for fishing gear. My guess would be that it would take a lot of effort to get fishermen to change what type of gear they use, though.
Yeah.
More expensive.
And that's it for the questions. Just a few notes here. Thank you for the excellent work. Nice presentation. And a quick note from Sarah to thank Oregon Sea Grant as well.
Oregon Sea Grant for funding. Yes. Sorry, Sarah. Thank you, Oregon Sea Grant.
Thank you to everyone. But otherwise, that is it. So that wraps our presentation for the evening. Thank you again so much, Toby, for joining us. Really great research. Things I hadn't even considered, and I learned so much. So this will be really great to have. And we did record this, so it will also be available on our YouTube channel for future learning and sharing if you'd like. And with that, I hope you all have a good evening.
Thank
Bye.
you. Bye.